Hello everyone, this is Mojtaba, and I hope you have enjoyed so far this NLP Summit. Today I'm going to talk about how we can extract or how we could manage to extract actionable insights from the feedback data using some NLP component like a topic modeling and sentiment analysis. Before going into bits and bytes of my presentation, let me start with a little bit of introduction about the organization. ING is one of the biggest banks in Europe and operates in more than 40 countries globally. We have roughly around 40 million customers, and we have something around 55,000 employees globally. So last year, when we were hit by Corona, all the employees were forced to go home and working from home. And one of the challenges from senior managers was that, okay, how we can measure the engagement of our employees and how we can find what are their problems and how we can solve their problems. So we have started running a work pulse, a weekly pulse survey, contains of some closed enclosed questions and two open text questions. We have been running the survey from last year, April 2020, and yeah, we received a lot of basically responses from this survey. We as a data scientist basically stepped in and to analyze all those open text answers and to understand, okay, doing a further analysis to understand what are the main topics our employees are talking about, and what is their basically sentiment around that, and how we can solve those issues for them. So we started with the architecture of our data science component. So what you see here is basically our final architecture. We started with a lot of experimentation, and you already know that some of these models we have, like a topic modeling or sentiment analysis, you can go with some approaches where you don't need labelings, but at the end of the day, you realize that those are not performing very well. So in this architecture, as you can see, we have a labeling as a starting point. Then after labeling, we have our models, topic models, and sentiment analysis model. After several experimentation, we reached to a kind of a point that our stakeholders are happy with the result. We deployed our models in production, and after deployment in production, we kept looking at our models to see that, okay, how we can further train it. What is the time that our model starts to degrade, and we need to basically take some actions in this regard. I'm going to touch upon all those components and explain to you how we managed to do it and how we did it actually. I will start with the labeling part. It sounds easy, but it can be one of the component or the reasons you introduce bias in your models, because it depends what is the pool of annotators you're using. So in this regard, we try to have a very wide range of annotators coming from the different cultures, different regions within organization, with different backgrounds as well, to minimize bias in our models. So each comment basically was we asked three annotators to annotate one comment. We did a majority voting to label each comment. After this exercise, we tried to calculate IAA, inter-agreement annotation, to see that what is the agreement between our annotators. If the agreement is so low, for us it was an indication that something is not clear for them. So in that sense, we try to update our instructions to make sure that everything is clear for them. So we basically kept this loop up and running for each time we try to label our data. So after labeling data, so it's a time that you can develop your model based on annotated data. So I will start with topic modeling. We define some predefined topics I have to mention, discuss with business. because we wanted to make sure that for each topic there is one business owner. As I mentioned before, at the end of the day, we want to provide them some actionable insights, and those actionable insights should go to certain team within organization, then they can have a look at it and take some proper actions. So that's the first point I have to mention. The second thing is that our metric for our model, especially our topic model, is a precision because we want to minimize our false positive. This is something is different from the domain to domain. So when you are working in a HR domain, so they are pretty sensitive that how your model performs. So that's why we try to keep as much as possible, uh, be conservative and minimum false positive. So the fact that we are running our surveys globally, we received text basically in different languages. In this regard, we decided to translate those different languages into English using Hugging Face API. And after that, so we do some post-processing on the text, like splitting text into sentences and windows. Let me explain a little bit more about windows. Means that sometimes we take a windows of 2 sentences or 3 sentences. The whole idea was that, okay, let's define the topics per 2 sentences or 3 sentences, basically not the entire comment. Each comment can be several sentences, and we wanted to narrow it down to 2 sentences, for instance. Then after defining this windowing, we applied some cleaning, removing all the stop words and nonsense words because we want to apply our models on top of those texts. Then after that, converting our text into some numerical values using some embeddings. In this case, we use a combination of the TF-IDF and ELMO because at least that's how it worked for us very well. And most likely it's coming from the fact that all the text we receive was a combination of short text or long text. And TF-IDF usually performs on a short text, and ELMO as a contextualized word embedding performs on a long text. Then after that, we applied the dimension reduction in order to keep dimensions with highest variance or with highest features and applying of multi-label topic modeling. The fact that embedding and multi-label topic modeling is an important component here, I'm going to explain a little bit further on that. So as I said, basically we decided to have a combination of TF-IDF and ELMO as a contextualized embedding for our conversion of our text into numerical values. And we try to also further optimize that because, and also it was going to help our models to perform better. So we try to optimize that. What's the contribution of TF-IDF and ELMO embedding in our combined embedding? We use hyper opt to optimize alpha in this case. Then for multi-label classification, how it works out is basically for a multi-label classification, you convert it to several single binary classification. And we use a change classifier change. It means that at the result of each single binary classifier goes to the basically will be an input of another single binary classifier. That's how we can basically take into account correlation between topics. As a classifier, we use basically XGBoost. That's how the best topic modeling worked out for us. Let's move to sentiment analysis. For sentiment analysis, as I mentioned, we tried different approaches using rule-based approaches without any labeling, and then using our label data and applied some, I would say, classical machine learning model, like converting to numerical values with some embeddings, then applying some classifier, and the performance was not good, or the performance was not as good as our stakeholder expected. So then our decision was that, okay, maybe we can go to train a deep learning model, but our data was not enough. And the only solution for us was to use some transfer learning, using a model already trained on a big data and large data, and we're going to use that trained model to fine tune it for our small data. So in this case, we use a BERT transformer, again using Hugging Face API. And as you can see, the architecture, all those lower levels layers are frozen, but we're gonna basically fine tune the top layers for our data set. That's how we managed to get the best performance from our sentiment analysis, where basically we were happy and the stakeholders were happy as well. So far so good. We managed to grab our text, clean it, convert it into embedding. Then after that, we applied our topic modeling and sentiment analysis to a level that our stakeholders and we are happy about it. And the last part is basically deploying in the production, how we're going to present this data to our stakeholders. So for the sake of confidentiality, I'm not allowed to, or not able to show uh, the entire dashboard to you and what are the different components we were basically presenting to our stakeholders. Just again, one more time, we use a Power BI because it was easy for us to manage user access there, and the visuals are quite easy to set up. For the sake of, I just picked out one snapshot of the visualization. You can see here, it shows at the same time topics and also sentiments. Again, for the sake of confidentiality, I remove all the topics names and change it to topic 1, topic 2, and topic 3, etc. You can see blue lines. Blue lines are basically indicate or represent the median values for net sentiment and number of comments. What you see here is that the comparison of the same topic from the last month and this month. And how do you read this picture is that, for instance, topic 9, you see that on the left bottom, net sentiment decreased with respect to last month quite a bit. And the comments, number of comments also decreased, -4%, you can see here. So that's how you can read for each circle in this plot. So it shows the net sentiment and number of comments with respect to last month, 2 months ago, or whatever basically comparison you want to do. The circle size shows that basically number of comments in these months. On the topic 3 and topic 7 was basically most common topics in these months. That's a good basically representation or visual for our stakeholders to do comparison between the current month and last month, even though they can do comparison with different part of the organization. You can think of, okay, you can do comparison between marketing and, or for instance, HR organization to see that how these topics are changing from a number of them from the sentiment perspective. So, okay, what I explained again, just to recap, labeling, applying our topic modeling with different approach, also sentiment analysis, we deployed in production, all good, but that's basically half of the way. So we need to also monitor our model in production to see that how it performs. And if it starts to degrade, we have to start retraining. So in this case, we started with active learning and how active learning works out for us. And how active learning works in general is that there is a new stream of data, unlabeled data, and your deployed machine learning algorithm starts to labeling those data or unlabeled data. We calculated how confident is our model in labeling data. If the model is not confident enough, then we're going to tag those comments or text for manual labeling, as you can see in this cycle. So those tagged comments or text goes for manual labeling, then we manually label those comments. Again, we retrain our model based on new set of data and deploy the model in production. That's the loops, basically, that's the loop we have in order to keep our machine learning algorithm up to date. It's also some sort of a measurement because we can see that how many confident label model is generating. If that one is decreasing, it means that, okay, your model is start to degrade. This is one advantage. The second advantage is that model is going to learn complicated patterns by manually labeled data. The third one is that finding the best comments to be labeled manually rather than easy ones. That's the one way of basically keeping our models updated and avoid any degradation in our model. This is not the end of the story. We can still continue with monitoring your model in production from several aspects. One is the software metrics. Suppose you have a Flask API or there is any other APIs in production, so you can see that how server load, memory latency, and throughput. And these are the software metrics. But let's put that on the side. We're going to focus on data science aspects. One aspect is the input metrics, how your input is changing. So changing the input or feature is called data drift. As you can see here, for instance, you see the age distribution in a gray one and also in red one. You see that in the red one, it's going to change. The distribution moving toward the older age. It's an indication that there is a feature drift. And this feature drift gradually will cause basically your model to degrade. So you have to watch them and you have to basically see that how this drift is happening. Another type of drift is a concept drift, when the patterns the model learn no longer hold. So it means that the relation of X and Y input and output is changing and the model is not relevant anymore. How it's going to happen? So suppose we have a feature, one feature in 3 times T1, T2, and T3, and you see that the distribution of this feature didn't change at all. But in T3 time, in certain area of this feature, the number of times class B predicted increased quite a bit with respect to time 2 and time 1. It's a time that, okay, there is a concept drift. Your model pattern, the pattern is no longer hold anymore. So that's the time that you have to step in there and fix this issue. So how we can calculate the data drift also is something interesting. In this case, we calculate Jensen-Shannon as a metric, how different are distributions. But how we can do this calculation is the following. So suppose we have a data reference. This data reference is the time, it's the data you use to train your model. And there is a data check, it's a new data, it's a very new data coming to your model. It can be input or output, it doesn't matter here. So you do bootstrap sampling from a new data and you do similarity check or using JS metric to see that how similar is your subsampling data with the reference data, and you can create a similarity array. You take the mean value of the similarity array and check it with some critical value. If this above a certain, if greater than this critical value, it means that there is a drift. So it's like a hypothesis testing. So if this mean of similarity array is greater than a certain value or critical value, your null hypothesis is rejected. If not, means that your null hypothesis is not rejected. So now the question is that how to calculate that critical value. There is a way to calculate this critical value. So again, you refer to data reference. It's a data that you trained your model. You do bootstrapping, subsampling, And for each sample, you created subsample, equal size of subsample, and you calculate the distance metric. And you do the same for sample number 2, sample number 3, and so on. So now you have a distance metric array, and based on that, you can plot a distribution. And in this distribution, you can define an alpha. Alpha is like a significance level or your confidence level. Based on this alpha is completely you define it, and it's a user defined, you can find a critical value. This critical value, if again, let me go back. If this similarity array mean value is above this critical value, it means that your null hypothesis is rejected. It means that basically there is a drift in your input data or your model output data. If not, means that there is no drift. So let me give you an example of our case. Here you can see that calculation of a JS score for May, June, July, and August. And our reference data is somewhere in, suppose, April or February. Our critical value is 0.23 basically. And you can see that in May, it goes above 0.3, means that basically our null hypothesis is rejected, but the number of data is not much. So it's not basically trustable. So let's put May aside. You can see that in June, July, and August. In August, we see that, oh, basically our null hypothesis is rejected and there is a kind of a drift in our model. The red line shows number of comments, and you see that the number of comments is not negligible. So August is for us is the indication that there is a drift in our data and in our model, and it's the time that we need to retrain our model. It's the time that we have to look into it, our model. Our model has started to degrade. So, okay, so far so good. Again, to recap, from beginning, I explained to you all those components, labeling, our modeling, it was a topic modeling or sentiment analysis. Then we deployed in production using Power BI. We had active learning to make it a bit smarter, our labeling exercise, and also it's some sort of a metric for our model. And the last part was monitoring itself, showing input drift and basically data drift, input drift, or concept drift, and how we can calculate that, how we can see your model is healthy and generating relevant results. I hope you enjoyed my presentation and looking forward to your questions. Thank you so much.